Pure energy.
Oh man, we got a physics project today.
That's electrostatic energy. That's the phenomenon of the branch that deals with slow-moving electric charges.
Well, let's get inside and get started.
All right. Ow!
What happened?
I got shocked.
What do you mean you got shocked?
It was caused by friction, dude.
What's friction? What kind of energy?
It's the potential energy of electrons. When I slid across the seat, I built up the charge, and when I touched the metal, it shocked me.
That sounded painful.
Alright, let's go inside and get
Alright, let's go.
this project. Here we go.
Dude, you see this?
Yeah.
That's crazy. What is that? What was that?
That is conduction. You are acting as ground.
I have to ask what conduction is before you explain
Okay.
it to me.
You were acting as a ground, and the plastic was negatively charged. When it was positively charged, and you were negatively charged. And so, positive and negatives come together, and that's why it stuck in your hand.
That's crazy.
I know.
Dude, let's go start this project.
Let's talk about induction.
What's that?
Well, let's go over there and find out.
Alright. Dude, what the heck is this?
This is a Van de Graaff. Doesn't everybody have a Van de Graaff
No,
generator in their kitchen?
not last time I checked.
Well, we can see the electricity jumps to induction when one electricity jumps from one other source to another. If you hold the light long enough, you'll get the shock. Like that.
That's crazy.
I know, right?
What is this and how does this thing work?
Well, you see, the rubber right here will spin from the motor, and the copper will touch it, and it'll produce electricity. And it's just like if you were running on carpet in place, building up that charge, and then touching metal objects and shooting the electric through.
So if this thing was on and I touched it, it would feel the same way?
Yeah, but a little bit stronger.
Well, then I don't want to touch it.
Well, that's induction.
Feel it over here?
Oh.
Do you want me
Here,
to put
let me give this a try.
Alright, sure thing, James.
Oh my god, yeah.
Ah.
Feel that in my hand.
Yeah, that's electricity, bro.
Look at those screws. That's crazy.
I know, that's like lightning. It's like mini lightning.
My own lightning storm here.
So, that's induction, folks.
There we go. Dude, why does this thing light up without any power coming to the other end?
Because the electricity is lighting up the gases and making them excited, and that's how you get the light, without it being connected.
That's crazy.
I know, right? It's like magic. Except it's science. Go.
So basically, we have seen 3 examples of electric potential energy.
Yeah, the first one was before we got even out of the car, when I had built up all that electric potential when I shifted out of my seat and touched the door handle and shocked myself.
Then I saw the second one when I opened the chips and I got the wrapper to stick to my hand.
Yeah, and then we saw the third one when you were using the Van de Graaff, and you were making the gas excite and get this to light up with the electricity, and all that potential went straight up into here.
Well, there we go.
I know, right? So we had one example of friction in the car,
One example of conduction.
and one example of induction with the Van de Graaff and the
Bulb.
fluorescent bulb.
So basically, we've had 3 examples of electric potential energy.
Right, the first one was when we were in the car, and I had conduction with friction that built up all that potential energy when I shocked myself with the door handle getting out of the car.
Then mine was when I opened the snack and the negative wrapper got to me because I was positive and it attracted to me.
Right, and then our last one was when we were using the Van de Graaff, because everybody's got one.
Who doesn't?
I know, right? When the electric static energy went from the Van de Graaff to the tube and it excited all those gases
And made it light up.
Yep. So we've had one friction
1 conduction.
and one induction. And that's all 3. So let's go watch the game.
Woo!
Yeah, come on!